Good morning. Welcome to TMMS Productions. Today we are going to solve Science Paper 2, that is Chemistry Paper of 2019 ICSE Board Examination. The paper consists of two sections. Section 1 of 40 marks, which is compulsory, and it will be mostly objective questions including MCQs. And section 2 will also be of 40 marks, which will have 4 questions to be attempted. So we have a choice of 4 questions to be attempted from section 2. So ideally, during the reading time, which is the first 15 minutes, you should read your section 2 and decide upon the questions that you will be attempting and plan your answers accordingly. Let's look at the paper. Chemistry Science Paper 2. It is for 2 hours and you will not be allowed to write during first 15 minutes. So these 15 minutes is your reading time. We read it well and plan the work. Section 1 compulsory and any 4 questions from section 2. So let us come to section 1, which is for 40 marks. Let us look at question 1. Choose the correct answer from the options given below. Number 1, the electrolyte which completely dissociates into ions. Completely dissociates means it will be sodium hydroxide. Number 2, the most electronegative element from the following elements is, now look at these here, these are all period 3 and so most electronegative would be chlorine, which is group 7A. 3. The reason for using aluminium in the alloy duralumin is C, which says aluminium brings lightness. Number 4, the drying agent used for drying HCl gas, hydrogen chloride gas, would be acidic, so it would be A. A hydrocarbon which is greenhouse gas is methane. This all of you must be knowing. It's a very common question. Come to B. Fill in the blanks with the choices given in brackets. Number 1. Conversion of ethanol to ethene by the action of concentrated sulfuric acid is an example of, now ethanol is C2H5OH is becoming C2H4. So one H and one OH has gone, so it is dehydration. Number 2. When sodium chloride is heated with concentrated sulfuric acid below 200 degrees C, one of the products formed is going to be NaHSO4. Where is it? Sodium hydrogen sulfate. So that's the one. Number 3. Ammonia reacts with excess chlorine. So it forms NCl3 and HCl. So what are choices? Yes, nitrogen trichloride. Number 4. Substitution reactions are characteristics reaction of, now substitution is where it's going to be saturated hydrocarbon. Which ones are saturated? Yes, alkenes. The 5th one. In period 3, the most metallic element is going to be on the extreme left. Which one it is? Yes, sodium. We come to C. Write balanced chemical equation for each of the following reactions. Reduction of copper 2 oxide by hydrogen. So that will be CuO plus H2 and that will give you Cu plus H2O. Reaction 2, action of dilute sulfuric acid on sodium hydroxide. Sodium hydroxide is NaOH plus H2SO4 dilute and that will give us Na will take SO4, so that will be Na2SO4 and we will have this and this giving us 2H2O. Third one, action of dilute sulfuric acid on zinc sulfide. Zinc sulfide is ZnS plus dilute sulfuric acid is H2SO4 dilute, and we will have Zn will go with SO4, it will form ZnSO4, and H2 with this S will be hydrogen sulfide gas. We come to ammonium hydroxide added to ferrous sulfate. Ferrous sulfate is FeSO4 plus ammonium hydroxide is NH4OH. And here we will have double decomposition reaction happening, and we will have FeOH twice because this is Fe2 plus, and that will give us ammonium sulfate, that is NH4 twice SO4. We come to chlorine gas is reacted with ethene. Now ethene is C double bond C, so that will be C2H4, and then we will have chlorine gas added to that, and we will have CCl4 inert solvent, and that will give us C2H4 Cl2. This will be an addition compound that is formed. Let us come to state 1 observation. Number 1, concentrated nitric acid is reacted with sulfur. Now we have concentrated nitric acid. So sulfur is going to become H2SO4 and we will have H2O and NO2. So we will have reddish brown fumes of nitrogen dioxide are evolved. Second one, ammonia gas is passed over heated copper 2 oxide. Now copper 2 oxide is black and ammonia is going to reduce it and is going to make it copper metal. And so we will have black CuO turns into pinkish brown copper metal. We come to copper sulfate solution is electrolyzed using copper electrodes. Now copper electrodes are active electrodes and they are going to replace the Cu2 plus ions, and so we will have blue color of CuSO4 solution does not fade. That will be the main observation. A small piece of zinc is added to dilute hydrochloric acid. Now zinc with hydrochloric acid is going to evolve hydrogen. So we will have colorless, odorless hydrogen gas is liberated. Lead nitrate is heated strongly in a test tube. You will say lead nitrate decrepitates evolving reddish brown nitrogen dioxide gas and leaves buff yellow residue. We come to E. Calculate the number of moles in 12 grams of oxygen gas. And number 2, the weight of 10 to the power 22 atoms of carbon. So let us look at question 1E. GMM of oxygen gas We find out first by multiplying 2 into 16, which is the gram atomic mass, and then we multiply this and we get 32 gram. Mass of oxygen gas in the question, it was given as 12 grams. So we write our statements. 32 grams of oxygen gas has 1 mole, and so 12 grams of oxygen gas will have X moles. X will be equal to 12 into 1 divided by 32, and 4 3s and 4 8s. So 3 upon 8, which is 0.375 moles, and that is our answer 1. For the second one, we have to find the weight of 10 to the power 22 atoms of carbon. Avogadro's number has been given as 6 into 10 to the power 22, and carbon has been given as 12. And so GAM of carbon becomes 12 grams. And so we write our statement. If 12 grams of carbon has Avogadro's number, that is 6 into 10 to the power 22 atoms. So how many grams of carbon has 10 to the power 22 atoms? So this X will be equal to 12 multiplied by 10 to the power 22 divided by 6 into 10 to the power 22. This gets cancelled, and 6 ones and 6 twos. So that gives us 2 gram, which is our answer. The third subpart says the molecular formula of a compound is C6H18 and O3. And so we will take the ratio. The ratio is C is to H is to O, is 6 is to 18 is to 3. So we will have the simple whole number ratio is 2 is to 6 is to 1, and therefore empirical formula is C2H6O, and that is our answer. We come to question 1F. First subpart. Give the IUPAC name of the following organic compounds. Now this one has the longest chain, 3 carbons, so it is a prop, and this is a triple bond, so it is propyne. Let us come to the second compound. Again, there are 2 carbons in the longest chain, and we have this, which is aldehyde group. So it is going to be 2 carbons is eth, single bond here is ene, and aldehyde group makes it al. So it is ethanal. Let's come to the next part. What is the special feature or the structure of ethyne? Ethyne has ine, so it's an alkyne. It is the presence of a triple covalent bond between the carbon atoms. Let's come to the third subpart. Name the saturated hydrocarbon containing 2 carbon atoms. Now 2 carbon atoms is going to be eth. Saturated means single bond, so it is going to be an alkane, and so our answer will be ethane. Give the structural formula of acetic acid is the next subpart. Acetic acid is CH3COOH. So C single bond C. Let us write this CH3. And C double bond O single bond OH. And that is our structural formula of acetic acid. Give an appropriate term defined by the statements given below. Number 1, the formula that represents the simplest ratio of the various elements present in one molecule of a compound. And this will be your empirical formula. The substance that releases hydronium ion as the only positive ion when dissolved in water is an acid. The tendency of an atom to attract electrons towards itself when combined in a compound, covalent compound, that will be electron affinity. The process by which certain ores, especially carbonates, are converted to oxides in absence of air is calcination. Number 5, the covalent bond in which the electrons are shared equally between the combining atoms is the non-polar covalent bond. Let us come to H. Arrange the following according to the instructions given in brackets. K, Pb, Ca, Zn in increasing order of reactivity. So you need to know your activity series well. So we will see increasing order of reactivity means you have to start with the least reactive. Least reactive will be lowest will be Pb. So first one will be Pb. Then will come Zn. Then will come Ca and then will come K. So you'll see potassium, then calcium, then zinc and then Pb. This is how we have decreasing reactivity. So increasing will be the opposite. Now look at the second one. We have Mg2+, Cu2+, Na1+, and H1+ in the order of preferential discharge at the cathode. Now at the cathode, more reactive, more difficult it is. So less reactive, from here you have to check which is the least reactive, Cu2+. So it will be Cu2+. So from activity series you have to go upwards. So if you can see this over here, MgCuNaH, the lowest is Cu, and then going upwards you will see H will be the next one. So H1+, and then we will come to Mg and Na will be right on top here. So Mg will be here. So followed by Mg2+, and then we will have Na1+. Now we come to the next one, which is Li, K, Na and H in increasing order of their ionization potential. Now ionization potential increases across the period and decreases down the group. So if you are looking at the ionization potential will be maximum when the element is at the lowest end, and so K will be the most reactive, so it will have the least ionization potential, and maximum will be right on top, which is H. So we'll have H, Li, Na and then K. That is how metallic character increases, and we are asking for decreasing order of ionization potential means increasing metallic character. So we will have the first one will be H, then will be Li, then will be Na, and then it will be K. So that will be our order of increasing ionization potential. Look at your fourth one, F, B, N, O. These are period 2 elements. Increasing order of electron affinity, which means I have to go from left to right. So I'll have to start with boron, then comes nitrogen, then comes oxygen, then comes fluorine. And so that is our order. We come to the next one, ethane, methane, ethene and ethyne. So now ethane. If you look at your ethane, ethane is C2H6, and so the molecular weight will be 12 to 24 plus 6, that is 30. If it is methane, methane is CH4, so that will be 12 plus 4, which is 16. Then we will come to ethene. Ethene is C2H4, so 12 to 24 and 4, that is 28. And then we come to ethyne, which will be C2H2, so 12 to 24 and 2, 26. And so by changing the order to the increasing order of molecular weight, I'll have to start with the least. So that will be methane, followed by 26, which is ethyne. Then comes 28, which is ethene. And then comes 30, which is ethane. So now we come to the end of our section 1. That was the compulsory section, and now we'll come to section 2. We now come to section 2. Section 2 is for 40 marks. There are 6 questions, out of which we have to solve 84 questions. So let us look at our question 2A. It talks about draw the electron dot structure of number 1 nitrogen molecule, number 2 sodium chloride molecule, and the third one is ammonium ion. And here we have the atomic weights given and supplied. Let's see how we write this. So in our section 2, question 2A, we will write electron dot structure, and first one being nitrogen molecule, we will first write its electronic configuration. Nitrogen has atomic number 7, so it becomes 2, 5 as the electronic configuration, and then we have the 5 electrons over here. They will place themselves as 2 here and 3 this side. Reason, we will need 3 more electrons to be accepted by this nitrogen in order to complete its stable electronic configuration, that is completing its octet. Now this nitrogen is going to share these 3 electrons of another nitrogen, so that this nitrogen will have 1, 2, 3, 4, 5, 6, 7, 8 completing its octet, whereas this nitrogen also will share these 3 electrons with itself, and so it will have 1, 2, 3, 4, 5, 6, 7, 8. So both will be completed their octet, and that is how we will have nitrogen with this nitrogen sharing 3 pairs of electrons, forming triple covalent bond with nitrogen, like so, forming the nitrogen molecule. Let us come to the second one, which is sodium chloride. Now sodium chloride, we write Na, which is 11 atomic number, electronic configuration 281, and chlorine 17 will have the electronic configuration 287. Now the sodium atom will show its 1 electron with a cross, and then chlorine we will show the 7 electrons like this. Now sodium needs to donate this 1 electron, and so it's donating 1 electron to chlorine. Chlorine accepts that 1 electron because it has 7 electrons in the valence shell. So chlorine completes its octet, and sodium also, because it has lost its 1 electron, it has completed its octet. And so as a result, sodium will have 1 electron less. It will acquire 1 positive charge. Chlorine has accepted 1 electron, so it will have 1 minus charge, and both will be now having the charge, sodium with the positive charge and chlorine with its negative charge. They will now be held together by the electrostatic force of attraction, forming NaCl, which is the compound. Now we come to ammonium ion, which is NH4 1+. Now ammonium ion, this is ammonia, the structure of it, the electron dot structure. Nitrogen with its small circles here, 5 electrons, and this cross is for this H, this cross for this H, and this cross here for this H. And so we have ammonia molecule. Now this is the lone pair of electron which is going to be donated to the hydrogen ion. Now hydrogen ion is going to accept this, forming the coordinate covalent bond. So you will see this ammonia as it is, and we bring in this H, and the whole structure will be now having a unit positive charge. Now we will show this as sodium with single bond H, this with single bond H, this with single bond H, and this lone pair has been donated to H completely. So we'll show the coordinate bond H, and that will give us with positive charge the ammonium ion, which is NH4 1+, and we write ammonium ion here. Let us come to 2B. The pH values of 3 solutions A, B and C are given in the table. Answer the following questions. So solution A is having pH value 12. Now this is more than 7, so this is going to be alkaline. B is less than 7, 2, so that is going to be an acid, and C is going to be 7, which is going to be neutral. Our first question, which solution will have no effect on the litmus solution? Now, no effect on the litmus solution means it is neutral, so it will be C. We come to which solution will liberate CO2 when reacted with sodium carbonate? It will have to be the acid. Now, acid is having pH less than 7, so it will be B, which is having 2 as the pH. Which solution will turn red litmus solution blue? This will be the alkali. Alkali is more than 7, so that will be our solution A. Let us come to the next question. This is based on periodic table. Study the extract of periodic table given below and answer the questions that follow. Give the alphabet corresponding to the element in the question. Do not repeat the element. Now here we have been given A, B, C, D, E, F, G. Now the actual elements we do not write. We write the letter corresponding to that element depending upon their position and the property. Which element forms electrovalent compound with G? Now G is over here, which is going to be your group 7A. Now this is the last one. This is your group 0. This is going to be your 7A or 17. This is going to be 16. This will be your group 15. This will be group 14. This will be group 13. These are your transition elements here. This will be group 2A. And this is going to be group 1A. So now you will see that this is your hydrogen and this is going to be your period 1, period 2 and period 3. So here sodium will be there and this is magnesium. Magnesium active metal. And now let us look at this G. So which element forms electrovalent compound with G? It will have to be B. So we will have which element? We will write over there element B. The second part, the ion of which element which migrate towards the cathode during the electrolysis process. Now you will see, now ion which will migrate towards the cathode will be the cation. Now A and B both will form the cations, but B we have already taken and we are told not to repeat. So here it will be A. Third one, which non-metallic element has valency of 2? Now valency 2 means it should have 6 electrons in the last shell. So it will have to be with group 16A, which is E. Which is an inert gas? This is simple. It is group 0, so that will be F. Let's come to question number 3A. Name the particle present in number 1, strong electrolyte. Strong electrolyte will have almost all ions, so we write ions only. 2, non-electrolyte, it will have molecules only. And weak electrolyte, it will have ions as well as molecules. Question 3B. Distinguish between the following pairs of compounds using the reagents given in the bracket. The first one is manganese dioxide and copper 2 oxide using concentrated HCl. Number 2, ferrous sulfate solution and ferric sulfate solution using sodium hydroxide solution. And the third one is dilute hydrochloric acid and dilute sulfuric acid using lead nitrate solution. Let us see how we write the solutions. So in our first part, we write the test, manganese dioxide and copper 2 oxide. We make the columns like so. And we'll write the test. They told us to add concentrated HCl to each. And so we will add and we'll heat it. If it is manganese dioxide, what we will get is greenish yellow chlorine gas is evolved. So we write like so and then we say then MnO2 is present. For copper 2 2 oxide, there will be no greenish yellow gas. So we write, if no greenish yellow gas evolved and the solution turns blue because copper will form copper chloride, and so then CuO will be present in that case. Come to the second part. The second part is ferrous sulfate solution and ferric sulfate solution, and we have to use the test of adding sodium hydroxide solution to each. And so with FeSO4, it's ferrous, so you will have dirty green precipitate form that will be insoluble in excess of NaOH solution, and then in that case we will write Fe2 plus is present, and therefore it will be ferrous sulfate solution present. But in case of ferric sulfate, if reddish brown precipitate is formed which is insoluble in excess of NaOH solution, then Fe3 plus is present, and therefore we will say ferric sulfate is present. Now here, in case you make a mistake, just strike it across like that. And so I kept this mistake here for you to see how neatly you can cancel. Do not make it dirty. We come to the next one, which is dilute HCl and dilute H2SO4. Now in this, you will see that our test was add lead nitrate solution. Now lead nitrate will give us lead chloride in case of dilute HCl. So we write, if chalky white precipitate of lead chloride is formed which dissolves on heating, then dilute HCl is present. On the other hand, with this we will have lead nitrate giving us lead sulfate, and so if chalky white precipitate of lead sulfate is formed, but this will not dissolve on heating, so we say which does not dissolve on heating, then dilute H2SO4 is present. Question 3c. Choose the method of preparation of the following salts from the methods given in the list. So we have A, neutralization, B, precipitation, C, direct combination, and D is substitution method. Our first compound is lead chloride. Now lead chloride is insoluble, so it will be precipitation reaction, so we write here B. The second one is iron 2 sulfate. Now iron 2 sulfate is formed with iron reacting with H2SO4, and iron displaces H, so that will be our substitution, so that becomes D. Sodium nitrate will be neutralization by titration, so we write A, and iron 3 chloride will be direct combination or synthesis, so we write C. Now we come to question 4. Complete the following equations: sulfur with concentrated HNO3, carbon concentrated H2SO4, and copper with dilute HNO3. So we write our reactions with sulfur and conc HNO3, S plus 6 HNO3 concentrated on heating gives us H2SO4 plus 2 H2O plus 6 NO2, and this is a gas. Then C plus conc H2SO4, we write the reaction C plus 2 H2SO4 conc gives CO2 plus 2 H2O plus 2 SO2, which is a gas. This is also gas. And copper with dilute HNO3, we'll write 3 Cu plus 8 HNO3 dilute will give us 3 CuNO3 twice plus 4 H2O plus 2 NO, which is a gas. Let us come to question 4b. Write the balanced equations for the preparation of ethene from bromoethane. Now just to save on time, I have quickly written the equations and I'll just explain to you as I read this. Ethene from bromoethane. Now bromoethane, eth means 2 carbons. So we have C2H5Br because we have ethane C2H6. So one H gets replaced by Br, so it becomes C2H5Br, which is bromoethane. And we add alcoholic KOH and we boil it. And so what we get is K will take Br, it will form KBr. One H will take this OH, become H2O. And we will have C2H4 remaining. C2H4 is ethene. We come to the second one, ethyne using calcium carbide. Now this one is a very popular reaction. You should know this by heart. Calcium carbide is CaC2 plus 2H2O, that is water, and that will give us CaOH twice, which is calcium hydroxide, and it will give us acetylene, which is a gas. Methane from sodium acetate, another popular reaction. So sodium acetate will be CH3COONA. Acetic acid is CH3COOH. So H gets replaced by Na and it gives us sodium acetate. And we add soda lime. Soda lime is NaOH with CaO and we heat it. And then we have decarboxylation reaction happening. And so you'll have Na2CO3 as one of the products. And this CH3 will take this H and it will give us methane, which is a gas. Name the following compounds. The organic compounds. A compound with 3 carbon atoms whose functional group is carboxyl. Carboxyl means it will be COOH group, and so it will be with 3 carbons. 3 carbons means prop, so it will be propanoic acid. The first homologue whose general formula is CnH2n. Now CnH2n is alkene. So the first homologue is going to be ethene. Eth means 2 carbons. Now the compound that reacts with acetic acid to form ethyl ethanoate is esterification reaction, in which acetic acid reacts with ethanol. So we write here ethanol. The compound formed by complete chlorination of ethyne. Now ethyne is C triple bond C. So there are 3 bonds in between. So with each time chlorine gets added up, you will have triple bond becoming double bond becoming single bond. So you will have 4 chlorines added to the compound, and the answer would be 1, 1, 2, 2. So there are 1, 2, 3, 4 chlorines. So 1, 1, 2, 2 tetrachloroethane. Now we come to question number 5. Question number 5a. Give the chemical formula of bauxite, that is Al2O3.2H2O. Number 2, cryolite, it is Na3AlF6. And third one, sodium aluminate, which is NaAlO2. B. Answer the following questions based on the extraction of aluminium from alumina by Hall-Hérold's process. Number 1. What is the function of cryolite used along with alumina as the electrolyte? Function number 1, to lower the fusion temperature from 2050 degrees C to 950 degrees C. Number 2, to act as a solvent because it dissolves alumina and increases mobility. Third one, to increase conductivity, as pure alumina is almost a non-conductor of electricity. Number 2, why is powdered coke sprinkled on top of the electrolyte? So we write the answer, powdered coke. Powdered coke prevents the oxidation of graphite anodes and prevents them from being consumed by formation of carbon dioxide and carbon monoxide, and it also prevents heat loss by radiation. Number 3, name the cathode from which aluminium is collected, and your third answer here is it is cathode, which is gas carbon lining. Question 5c, match the alloys given in column 1 to the uses given in column 2. Duralumin will be for aircraft body, so we write C for the first one. Second one, solder, it is used as electrical fuse, so we write A for the second one. Brass is used for decorative articles, so we'll write D for third one. Stainless steel is used in surgical instruments, so we'll write B in the fourth one. Question number 6. A. Identify the substances underlined. The catalyst used to oxidize ammonia is platinum. We come to second one, the organic compound which when solidified forms an ice-like mass is acetic acid, which is also ethanoic acid. Better to write both. Number 3, the dilute acid which is an oxidizing agent is dilute nitric acid. Remember, even in 1% dilution, it is oxidizing. Now we come to B. Copper sulfate solution reacts with sodium hydroxide solution to form a precipitate of copper hydroxide according to this equation. What is the mass of copper hydroxide precipitated by using 200 grams of sodium hydroxide? The atomic masses are given. And what is the color of the precipitate formed? So for our solution, we will write the equation like so, as it is given in the paper, and we will write the question. 200 grams of NaOH will give us how much of mass of copper hydroxide. Now because these are masses over here, we'll have to find the gram molecular mass of NaOH as well as copper hydroxide. The atomic masses are given, so we write GMM of NaOH will be Na is 23, O is 16, H is 1, add, you get 40 grams. So we'll write in the equation 2 into 40 grams. Then we find the gram molecular mass of CuOH twice. Cu is 64 as it's given in the paper, and 2 into bracket 16 plus 1. Oxygen is 16, hydrogen is 1. So that gives us 64 plus 2 into 17, that is 64 plus 34, that is 98 gram. Now we will say if 80 grams of NaOH forms 98 grams of CuOH twice. So 200 grams will give us how much? And so mass of CuOH twice will be, these two numbers will cross multiply, divide by this 80, cancel the zeros, 4 will divide twice, it will go here 5 times, and 2 goes here 49 times, 5 9s 45, carry 4, 5 4s 20, and 4 24. So 245 grams is the answer. Now the second part says the color of the precipitate, that is CuOH twice, it is pale blue, and that is our answer 2. Now let us come to the C part. Find the empirical formula and the molecular formula of an organic compound from the data given below. C is given this percentage, H is given as this percentage, and N is given as this percentage. Vapor density is given as 39.5, and we have the atomic mass is given. So we will write all this on the paper, make the columns, and we'll solve it. So now we make the columns. The first column is for element, so we write the elements. Percentage is the second column. We copy these percentages as they are given in the question. Atomic weight as they are given in the question. Now relative number of atoms, we will take the percentage divided by atomic weight. Again percentage divided by atomic weight. Percentage divided by atomic weight, like so. The calculations I have shown here. 6.32, we are getting here again 6.32, and here you will see it is 1.26. You can see the calculations here, and so we write the quotients over here. We have to take the simple ratio from here, so we take the lowest and divide each one of these by the lowest. So 6.32 upon 1.26, which is giving us 5. See the division over here, it's going 630 here, balance is 2, so it's going to be 5, and here it will be again 1, so we have 5:5:1. That will give us our empirical formula as C5H5N, which is our answer 1. Next step is to get the empirical formula weight. Carbon is 12, you can see that 12, so 12 into 5 is 60. Then hydrogen is 1, so 1 into 5 is 5. Nitrogen is 14, so we write here 14, add it up, 79. Next step is to get the molecular formula weight, which is 2 into vapor density. And the vapor density has been supplied as 39.5 multiplied by 2, that is your 79. Our next step is to get N, that is molecular formula weight upon empirical formula weight. And that is 79 upon 79, which is 1. And so we have molecular formula equal to N into empirical formula means 1 into C5H5N, which gives us C5H5N, and that is our answer 2. Let's come to question number 7. Your A part says name the gas evolved in each of the following cases. Number 1, alumina undergoes electrolytic reduction and the gas evolved will be oxygen. Second one, ethene undergoes hydrogenation reaction and the answer is ethane because ethene will have hydrogen added to it. It's an addition reaction, catalytic hydrogenation, and so we get ethane here. Ammonia reacts with heated copper oxide. Here ammonia is acting as a reducing agent and so it will get oxidized to nitrogen. So we have nitrogen is the gas evolved. We come to part B. Study the flowchart given and give balanced equations to represent the reactions A, B and C. So we have magnesium nitride with A reaction becomes ammonia. Ammonia with B reaction becomes ammonium chloride, and ammonium chloride with C reaction gives back ammonia. Now let us see our reactions which I have written over here ready so that we can save on the time. We can quickly look at this. So A reaction is Mg3N2 plus 6H2O, which is warm water. It gives us 3 MgOH twice plus ammonia, which is a gas. The second one was with ammonia gas we get ammonium chloride. So we can have hydrogen chloride gas and that will give us NH4Cl, which is a solid. Ammonium chloride is formed. C reaction was where we had to take ammonium chloride and get back ammonia. So we will add calcium hydroxide and we'll do double decomposition reaction here. So we'll need 2 molecules of NH4Cl that will give us Ca. We'll take this Cl, it will form CaCl2, and 2 NH4 will take 2 OHs and it will give us 2 H2O and 2 NH3, which is a gas. Now let us come to the last question of the paper. Copy and complete the following table which refers to the industrial method for preparation of ammonia and sulfuric acid. So now for ammonia, the name of the process is Haber's process. And the catalytic equation will be N2 plus 3H2 with finely divided ion, promoter molybdenum. So finely divided ion is the catalyst, promoter molybdenum, temperature 450 to 500 degrees C and pressure 200 to 900 atmosphere. We get 2 NH3 plus 22,400 calorie. For sulfuric acid, we make the table here, or we can just write 1, 2, 3, 4, one below the other, and we write the third blank as contact process, and the reaction with the catalytic equation would be SO2. So it will be 2 SO2 plus O2 with vanadium pentoxide as the catalyst, 450 to 500 degrees C temperature and 1 to 2 atmosphere. It gives us 2 SO3 plus 45 kilocalories. And that finishes our section 2. So I have solved the entire paper, but you have to solve 4 questions from section 2 according to your choice. So I hope that you had clarity about how the paper had to be solved. I hope that you will get good marks if you had appeared for 2019 ICSE board examination. The result is in May 2019. So all the best for you. And for the 2020 onwards board examination students, I hope that you have understood the pattern and also how to present your work. All the best to all of you. Thank you for watching.